Welcome to Token Economics, the podcast about FinOps for AI by Profisea Labs, where international CTOs break down what AI really costs and how to make every token count. Hosted by Ariel and Ariel from Profisea, a leading AWS and GCP premier partner, working with scale-up startups like 7AI, Zenity, and Groundcover from all over the globe, named as Rising Star Partner, last reInvent, Vegas' most glamorous event.
So good morning to all CTOs, VP R&D that are listening to us and thinking, what can we do with our enormous AI bill? Today, it's our first episode for Token Economics podcast. And I brought Anton Grishko, which is Profisea's chief architect. I work for almost 3 years with Anton, and he's super talented architect and DevOps engineer, and is in the forefront of technology and AI today, of course. So Anton, please introduce yourself, and we will start.
Yeah. Hello, Ariel. My name is Anton Grishko. I'm technical guy for the whole my life. Was DevOps architect, DevOps team lead, was also platform engineer and platform lead, was building multiple different products for multiple different companies, was participated in a lot of migration projects, optimization projects, and data projects. A lot of things was done, and a lot of things still need to be done. That's short about me.
Cool. So Anton, first of all, I want to hear a bit more about the things that you are building today. If you can share really high level so that our audience will know what you're focusing on today. And then we will start speaking about FinOps, which is why everybody came for.
Why we're here, exactly.
Yeah.
Let's in few words about what we're building. We're currently with the team building 2 different products. One product is focusing on DevOps and cloud. Another product is focusing on developers and making their development process much better when they're developing together with the Claude Code and other AIs. Everyone currently knows that if you will build, for example, a graph of something that you're working with, AI will start understanding this data much better because you build the graph for that. But what no one realized and no one tried at the moment is to build the graph for infrastructure, is to build the graph on top of what you actually have inside the AWS, what you have inside the Kubernetes, what you have inside the state files. Why you need that? Because if you will feed that to AI suddenly understands your infrastructure. AI suddenly understands where the breaking points are, and it's much accurate and much better with reasoning. So this is what we're building. This product number 1. It's called Kuberly. Kuberly is platform engineering product, and the whole aim of this product is basically to give the bridge between the DevOps engineers and CTOs, developers, and so on, so that developers can do the self-service, so that they can do updates without involvement of the DevOps engineer. And a second product, we call it DevMind. There are a lot of things which are called DevMind. We just call it DevMind by Kuberly. DevMind is just a sub-product which we built as a part of Kuberly. As a part of Kuberly, we had to build a memory layer, something which is memorizes what you're doing with AI, memorizes what you're doing with infrastructure. So we had to build the same for developers, just for the coding issues. And we put all the repos, best practices inside the AI, inside the databases. We're sharing that with customers, and it's giving much better results when you're coding. That's a nutshell.
Cool. Yes. Wow. Okay. So first of all, from what I saw, people that see DevMind, I think you need to call it a mind blow because people see it and oh my God, I can't believe it's just what I need. So that's perfect in that sense. Before we start with the FinOps, I want to hear from you what's the coolest thing today about AI.
What's the coolest thing about today
Not
about
about
AI?
AI, but that is possible with AI that you're super like amazed from.
Yeah, right now I am amazed about the everything which is related to context. It's called context fabric or context layer or context engineering. You may be heard about that. Um, I'm amazed about that. I'm amazed that basically any company can put all the data inside what's called AI brain. And if you will do that, then AI understands your business, understands your logic. And what I believe, AI is currently public. Everyone can use with AI, but AI doesn't have access to your business data. It doesn't have access to your business workflow, which is the private data. And this is the next step where AI will go on. This is where market is moving. Everyone are trying to build a memory on top of their private data and give it to AI, so AI can use it in a private way.
Cool. Yeah. And really, like, as you said, it's like the business data. It's like the most precious data for all customers. So also in the FinOps industry, it's super, super sophisticated to figure out things without compromising security. What
Mhm.
is your take on that issue? Like, how
Yeah,
can
this is
products work with the most uh, dangerous data of the company? How is it possible?
yeah, this is very good question, and it's already related a little bit to FinOps of Gen AI, which we'll discuss in a few minutes. Um, the problem with Gen AI and with actually measuring what you are using there inside the Gen AI is that you need to intercept the actual conversation. You need to intercept the actual context. You need to measure the context. You don't need to measure what's inside the context, but at least you need to measure what was the input, what was the output, who replied, what replied, how many times, how many turns or cycles there were. And that's the problem. If you start collecting the data, and if you're sending this data somewhere outside of your premise, so for example, sending to some SaaS solution, then you're risking that they're not actually collecting your actual charts, your actual context. And let me remind you that the context is actually your data. That's your business logic. Let me even emphasize it even larger. That's how Chinese are stealing data. That's how Chinese are stealing the models. For example, when they're doing distillation over the real models, they just asking the models to give all the secrets. So that's the problem. If you will start sending the context data somewhere outside of your company, it's a big risk that someone will just take your data, will train, and will build the same business. Because right now, to build the software is very, very easy.
Yeah, it's anyway super easy to mimic businesses, but when you have the internal data, it's
It's hard.
even,
It's
yeah,
hard when you
it's
have data. Yeah.
super big risk. Let's speak about FinOps. I know everybody
Let's
came here for the dollar bill, so let's speak about that.
let's speak. And I want to show a small presentation. So let me share my screen, and we will go over it. Tell me if you see it.
Yes, we can
Yes,
see it.
perfect. Okay, so what you see on my screen is basically a breakdown of my token and cost usage for the last 30 days. So for the last months, this is what I spent on the coding problems. Of course, you can have like different AI agent systems with different goals, but I will just show you an example on my own spend of the tokens and what we can do with that. So first of all, what is seen on my screen is that for the last months, I spent almost $14,000 if we would pay that as API key. We're paying something as a personal because I'm developing personal on my laptop, but also there are autonomous agents which are running in the cloud, so we're paying for them as well. But anyway, if you will take a look on that, you will see that majority of tokens spent were cash reading the cache. I will explain what it is in a few minutes. And another part is cache write. So basically, if you will take a look, that almost 100% of the tokens are sitting inside writing to the cache and reading from the cache. And if you will take a look on money-wise, you will see that 68% of the money spent on a cache read and 20% spent on a cache write. So we can say that 88% of all tokens spent are writing to the cache and reading to the cache. That's it. So let's apply to that a FinOps practices. What FinOps practice is saying that you need to take a look on breakdown and you need to focus on the largest category, which is in our case, cache read. So if we have here 68% cost usage, so let's focus on the cache read. Let's figure out what's inside the cache and let's figure out, can we decrease it? Can we make it smaller? So let's take a look what's inside the cache. Inside the cache is your context. So when you, for example, chatting with your ChatGPT, you have like 0 questions, then you write in the first message, and this message right away goes to the cache write. So it goes to the cache. AI is giving you a reply. Now you have 2 answers, like you have 2 messages in a chat. That's 2 messages in a cache, in a context. You add in the third one, the third answer is giving you the 4th reply. So now you have 4 inside your cache. And each time when you add in one more additional like question, it's going back to the cache, reading all previous questions, adding your additional question, then giving you the answer, and then everything is repeating. This is called turns of cycles. We'll discuss about that in a
Anthropic are building houses from this context gathering, I guess.
Correct. Yes. So let's take a look on more deeply inside the context. So what we have inside the context, there is a static usage of the tokens. What that static is the system prompts. So there are system prompts. In the latest Fable model, the system prompts become much lower than comparing to Opus. But you need to know that anyone can change the system prompts. You can change the system prompts. You can make it smaller. That's first. Second, tools. Everyone knows that there are MCP servers and MCP provides tools. But the problem with the tools are auto-advertised. What that means? It means that AI receives the details and schemas about all the tools that you connected. So for example, you connected one Jira MCP. And Jira MCP has 56 tools inside. And all 56 tools are always included in your context with all the schema and description. And you are moving all those like context, each question, each turn. That's crazy. So that's first. Second, message itself, which is the history, thinking, results, the ask. That's the second part of the context. Moving next. Turns. I already talked about the turns, that you have like a first question, then a second, and it's going bigger because you have this linear growth. But what people don't know about turns, or what they don't realize about the turns. Let's imagine a situation that on a turn number 3, we can call it steps, doesn't matter. Like on a step number 3, we, for example, are receiving the answer from one of our tools, and this answer is huge. It's a JSON file, like 1 megabyte. It's huge. That's it. This 1 megabyte reply from step number 3 will be moving to the step number 12 or each the time. So we loaded the huge context on step number 3, and then we'll be adding this huge context to the step number 4, step number 5, step number 6, and so on and so on. So one wrong reply for one of your tools or one of your CLIs or one of your databases, and that's it. The whole context is huge, and you're paying a huge amount of money because you're moving this huge amount of the context.
So the cost of mistake is super big here.
Huge. It's huge. And you know what's the problem with all of that? No one is measuring it. The market is blind. The market is like measuring the wrong things, the wrong metrics. No one is measuring this.
I can tell you, Anton, all CTOs I speak with, the only thing they care about right now is how to reduce FinOps cost. Really. No more cloud cost, no more, I don't know, CIC, nothing. Only how can I lower my AI bill? And also you can see that the cloud bills of the customers is becoming like cloud 50 and AI 50. And customers that are with an agentic product, it's even more. So it's becoming super big part of the bill, super unpredictable, and everybody's stressed around this issue.
That's true. Let's move on. Let's take a look on one more thing. So we discussed MCP tools, we discussed the turns. What we didn't discuss that if you will take a look on a breakdown of what actual tools used by your AI, you will notice that majority will be CLIs. For example, bash or grep or find. So majority of the calls will be using the local CLIs from the Linux or from macOS. That's the reality. So take a look on that. I have 158 tools, but from the MCP, but those tools even not half of what I'm spending on a bash. That's just an example. So even if you will start focusing just on MCP tools, maybe it's a wrong side. Maybe you need to focus on the CLIs first. And there is a ways to reduce that very, very drastically. How to reduce not the usage of the CLIs, but the amount of the tokens used for the CLIs. There is a ways and tricks how to do that. I will speak about that in a few minutes.
Anton,
Okay,
I have a question.
Go on.
Most startups, they care about one question. What is the low-hanging fruits? If you speak with a lazy team, not lazy, but don't have time for FinOps sheet, what is the lowest effort and biggest impact?
Lowest, yeah, this is working with the tools. Give me 5 minutes. I will go there. Okay. I have a slide about that. Yeah. Let's really quickly go through the few slides. So tools read not interesting. Metrics. I already told you that there's no metrics at the moment on the market, which actually we need in order to calculate everything to figure out where we're actually spending our tokens. I saw that OpenTelemetry is working in this direction. There are already some metrics available from them, but still not enough, not everything. I created a list of metrics that I need personally to figure out what kind of usage we see. And take a look. It's a cache write tier split. What I didn't tell you, Anthropic API has 2 caches, not 1 cache. There is a 5-minute cache and there is 1-hour cache. And both of them, they have different price. So 1-hour cache costs 2 times more comparing to just the regular cache. And the 5-minute cache costs 25% more than just the regular. This is just for your information. So as you see, a lot of metrics we can implement. We see this data, we can extract this data, but at the moment there is no monitoring tools or solutions which are doing that. Example, tool calls count, result size. This is what I told you that Samsung replied to us. Let's measure the size of this reply.
Anton, sorry for interrupting again the presentation, but okay, once I have this data, how do I make my developers change? Because, okay, this affect this and this, and how can we make it money?
It's a good question, but it's not only how you developers will make your developers much better. I will show you in later slides that, for example, once I implemented those metrics, I noticed very important, anomaly in my usage. I noticed that 10 sessions out of my 1,000 sessions, 10 sessions spent 70% of all tokens. So I found that only 10 sessions spent almost everything. And you know what I found? That the agent just go to the loop, and it was like constant loop. Agent was fixing the bug, introducing new bug, then fixing the bug, introducing previous bug. And it was a loop, and 10 sessions consumed almost all tokens. If I would have those metrics, I would stop it much, much, much earlier and wouldn't. So it's not only about like forcing your developers, you can catch actual problems right away and stop it. That's why you need the monitoring for Gen AI.
Mm-hmm. So you say the monitoring here is very important part of being in control.
I will say you even different. In the AI world, you cannot trust anything. You need to have metrics and data to prove it. So in order to get metrics, you need to build a monitoring solution. And once you have the metrics, then you have a data that you can rely on. Then you can test what's helping, what's not helping. You will see if the metrics going up or going down. So that will be your measuring. Okay, now let's think about another problem. So we discussed that there are turns, right? So what turn mean? It means that AI is looking for the right answer. So it's clear that if AI will find the right answer quicker, you will have less turns. Less turns, less token usage, right? So if your
Mhm.
AI is smart enough to understand your data, you'll be getting results faster, you'll be spending less. Okay, so knowing that, I decided how we can measure the efficiency of this, like searching for the correct answer. Can we actually measure that? And it turns out, yes, we can, because there are a lot of metrics. Those metrics were invented not for AI, they were invented for the search engines many, many years ago, but it's the same concept. We can ask a question, get the answer, and take a look if the answer is correct, and measure when it is going to be the correct answer. And this is what I did. I took the metrics. There's two very important metrics. Everything else is supporting. Important metrics is hit and MRR. So hit is, did we actually find any usable answer? So we ask a question, it replied to us like many, many options, and we check if there's anything useful for us. And MRR, this is the metric that basically calculates, is the right answer on top of all those options. So if I get a reply of 10 answers, is that the correct one? And where the correct one? Is it like number one, it's number two, or number three? Of course, it's better to have number one. If the correct answer is the first one, perfect, you have less turns. So I took those metrics. We're not going to go over each metric. It doesn't matter. How early does my find first usable result appears, for example? I will skip it. And pull recall will skip it as well. And we'll just tell that having those metrics gives you ability to measure how efficient your search. And when I measured the search for example, Claude Code, just the Claude Code. Claude Code not by default. This is the only way to do that. Claude Code is doing the grep and find behind the scenes. And because it's doing the grep and find, it's actually looking the files and lines inside the files each time when you're working with that. And the efficiency of that is only 17%. Only 17. So the Claude Code is finding the correct file and correct answer only on the fifth turn, usually. That's crazy. What we can do with that? This is about the 10 sessions which I discussed to you, that I found that 83% of input and 80% of the cost was only 10 sessions, which just stuck. This is what I explained.
Is there option like to set limit per session? Like
yes. But that one is based on the developers. But yes, there's a way to put a limit, a cap, and a lot of companies and engineers doing that. But again, it's not saving you from some like you can interrupt the conversation in a mid because you put a very small amount of tokens limit, right? And you got like a big response. So you still have this problem that you need to avoid big responses. So you need to work not with limiting your cost. Yes, you need to put some limit, definitely. But mostly you need to work with what's coming to you. How much of
you need
tokens
to
incoming
get the good results, that's for sure.
Good, and as fast as possible, the correct one. Okay. So let's now talk about what you can do about all of that, right? So this is the implementation phase. Like what you can do. You can, first of all, you will need to log everything. You need to implement the monitoring solution. You need to implement the metrics, which is count everything, measure everything. That's like clear. Without metrics, you're just blind. You don't know what's happening. So you need to build the monitoring metric solution. This is the first. Second, once you build it, you can start working on the problems that we already know and you already saw. We already discussed that there is a problem that we have a lot of tools and everyone has a lot of MCP tools, and all tools is always loaded to context. And that's the problem. We need those tools. We don't need those tools. They are loaded. So can we fix that? Yes, we can. Let's take a look all the tools, all the descriptions, all the schemas, and let's put it to database. In our case, let's put it to graph. A lot of people knows about the graph, so let's put it in a graph, and let's build another tool which will be searching based on the context inside this graph, the tools that we need. I called it tool dispatcher. So basically building a smart tool which is looking for other tools. So it's your dispatcher. It's something which is looking for which tools to load for you. And take a look on results. I had 61, so I had 164 tools, and those tools are 57K tokens. And I was able to reduce it to only 9K tokens. So this one, the green is 9K tokens. So I was
Everything
always,
is on Claude Code, all these numbers?
yes,
Amazing.
same. Yes. So it's more than 3 times. You can just 2-3 times you can per session decrease it simply by implementing the tool, which is basically a search for other tools. So don't load all the tools, build a search, which will be loading only the tools that you need during this session. That's first. Second, I talked about responses. So your AI made a question and it got a response, and the response is huge. And what AI is doing then, it's loading the huge response in a context, and then it's looking inside the response what it's need. So for example, imagine a situation that you're looking only at 3 words, or you're looking 1 sentence, but your AI is loading the whole page, and then it's going the whole page just to find this one sentence. So you lost a lot of tokens. What we can do with that? Let's take this huge response and let's put this huge response to our internal cache. And let's give AI ability to do select and where inside this data. So instead of loading the whole page, let's give our AI ability to search exactly only the one line. So it's searching exact one line, not loading the whole context to itself. There are a lot of ways to do that. You will need to have a Redis. You will need to put this cache inside the Redis. And what to put? There are a lot of languages. There is a Cell language. There is a Lua. It's mostly scripting languages. This is what you will need to do in order to put this data to some local temp cache from where you will be able to read it. So this is the second thing that you can do and you should do. Load your responses to the cache, read responses from the cache. Don't give the response directly to the MCP, if directly to the AI, if you know that this response can be huge. Simple enough, but no one is doing that.
And I have a question, like, can you somehow do the prompt in a way that he will be aware of FinOps and be more effective on his side? Like Claude? Like to teach him, this is the rules, you cannot do this, you cannot do that.
Yes, but this is the part of the solution. So what I've shown to me, it's a part of that. Claude Code supports what's called plugins. This is a different topic, by the way. Claude Code has its own plugins, and what people also don't know, that Claude Code gives you ability in the config to change the output. If you take a look on what Claude Code is outputting you and how big it is, you will realize that you easily can save like a 20-30% of the tokens simply changing how Claude Code is giving you the answers in how they look like, those answers. You can decrease it simply by changing that. It's a part of the Claude Code CLI. You can do that. And plugins are really important, because when you build all of this, like for example, you build a cache, you build what I mentioned to you, a tool dispatcher, you measuring everything, then you can build a Claude plugin, and Claude plugin will know about all of that. So instead of like doing the using the CLI tools, it will know that first of all, it needs to go and check inside the database if it has a cache, for example. So this combination of plugin and config, and plus putting all the data inside some cache, will give you very, very good results.
Anton, and another question that a lot of customers ask is like, how can I choose model? Because you want very, very good answers, but you don't want to pay very, very big money. So
yeah, this is the my take. First of all, the difference between models are so insignificant right now. Take a look on Fable and Opus 4.8. Yes, Fable is better, but did you saw the performance boost when you are coding with Fable? Did you saw that your code become better did you saw that you can close more tasks? No, it's like a little bit. Yes, it's smarter. So where the whole like benefits are coming from? It's coming from improving your harness. Don't focus on switching to the model. Focus on making your harness better. What the harness? This is what we're discussing, is looking for the right answer on a first try, is giving your AI agents context about your business logic, business data, and so on, about your repos or whatever you're working with. That's what you need to focus, harness.
And if you do this good, you can use shitty model and get good results?
Yes, but not like shitty. But I can tell you that I can get almost the same results on Opus 4.6 comparing to Fable. Yes. And even on shittier models, you can get better results. I can tell you that I measure that once you implement in all of what I'm showing you inside these slides, you're getting your AI agents getting the correct answer 80% of the time. And when you're getting the correct answer 80% of the time, your agents are smarter, they're closing tasks faster because there are less turns, and it's less using tokens, which is less money.
So it's cost effective and time effective.
Cost effective, efficiency effective, and time effective. Correct. All three. Yeah. Yeah, let's move on. A few more slides and that's it from my side. We discussed, I want to talk about the vector, which is also called RUG. Like you can put the data and you can do the learning process on top of the data. Let's call it like that. It's simpler. And once you put the data inside the vector, AI will understand it and AI will understand meaning. This is important. I will give an example. I mentioned to you that when you, for example, coding with the Claude Code is doing the find and grab behind the scenes. But find and grab is the CLI tools that looking for exact wording. So for example, if I'm looking inside the code, show me business logic about our ordering process. Graph will not find it. Because if I didn't specify in the code some comment that this is the ordering process, there is no word order or processing in my code, for example. So it won't find it. It will be a problem. But once you add in the vector, once you teach AI on top of your data, then it knows the meaning. Now you can ask the question.
Tagging.
Exactly, like tagging. It's tagging and classification correctly. So you did it, and after that, you can ask a questions like, show me business logic about the order process. And it will show you not only in one file, it will search over all your repos, all your code. It will show you the connection between them because now it understands the meaning. And this is more important, to give the meaning understanding to your AI. And this one is given this first results on a first turn, on a second turn. That's what's giving the 80% results. Now, but let's go above and beyond. We discussed that like 47% of all my usage is actually CLIs, is bash, grab, find, and so on. What we can do with that? Probably no one realizes that, or no one take a look on that, because everyone is using the Claude Code. My recommendation that, hey, try to use the open source open code. With ChatGPT, it will be worse, but it's not the point. The point is that open code gives you the transcription of all the tool calls, the calculation of everything. And if you will do that, you will notice very interesting thing about the usage of CLIs, how AI is using the CLI. So for example, it's running the bash command. And for example, the bash command is incorrect. It's like it generated the incorrect command. So what AI will do after that? AI will run the help. It will run the bash help. And guess what? The whole help will be loaded into your context, and voila, now you're going over all the questions with the help of the
New
bash.
houses are built for Anthropic CEO and C-level.
Yeah, that's like, yeah. Okay, so what you can do with that? Let's take a help of the bash, of grab, of find, of everything else. Let's take it books, documentation, like actual books about how to write a good bash, how to write a good grab, how to write a good Linux commands. Let's take a look at those best practices. Let's take a look at examples, and let's put it inside our database. Let's train on top of it, and let's ship it to customers. And this is what I did. And it dropped the usage of CLI tools drastically. Why? Because now AI has all the knowledge about how to use this tool. It now knows how to build the correct query first time. The graphs, I already talked about that. Everyone is doing graphs right now. There is a project called Graphify, open source. And this project, open source Graphify, is building the graphs on top of code. This is specifically for code. So you have a repo of Python, Java, JavaScript, and your Claude Code is working not so good with the code. As I mentioned to you, grep finds only 17% in the time. So if you build a graph, everything become much better. But then you will face a new problem that if you have 10 repos, for example, you build 10 graphs. So now you need to build something on top of them. You need to build what I call graph of graphs, like index of any other graphs. But this is the reality. If you have many graphs, you have the same problem that you need to load each graph one by one. So you need the index of the graphs. So just building, I'm trying to say that just building the graph is not enough. You will realize really soon that it's not enough, that you need to build a graph of graph. Once you build graph of graph, you realize that it's also not enough, that you will need to build a vector and so on. I'm just saying. Now, tagging, this is what you said, Ariel. This is the actual machine learning. This is what industry was talking about for years, but no one was actually using that except few companies who were calculating some kind of rocket science or electricity usage or something like that. But in reality, we all should use it. It's time to start using all of that. Everyone heard about embedding models, classification models, heuristic models, but no one is doing that. Why? You need to do that. Once you collected all the data, run the machine learning process on top of it. Run the embeddings and classification. Why you need that? Because it will put the tags on your data. And heuristic, this is the methodology which will fill in the gaps. So for example, you collected the data. I will give an example. Example from the Kuberly. Like why Kuberly is really good with working with infrastructure for developers and companies. Because we built a graph from the state, from the Kubernetes resources, from Terraform resources, from Terraform code itself, from Argo CD. So we built many graphs. We combined all graphs together and we run heuristic on top of them. What it gives? Heuristic checks all the graphs, fill in the gaps and fill in the description. And it also looking for the connections between them. Example, I have a resource inside the Amazon, and this resource from Amazon correlates to the code in my Terraform. And also this resource from Amazon correlates to the Kubernetes resource. And it correlates to the logs, and it correlates to the metrics. And all of that can be inside your vector database, and your Claude Code can be searching over it instead of searching over the files. Okay, that one I explained. That one I will skip. That's not important. Memory. This is what DevMind is doing. I mentioned this product, but what I didn't mention to you, the Claude Code has the sessions. You probably saw those sessions. The problem with the sessions that they're only stored on your laptop and only for right now. That's it. So tomorrow you will need to start from scratch. So there is no history of the sessions. At least there is no history of the sessions of the company. But I need the sessions.
Also a developer experience, because if the developer, it's super easy for him to run with AI and you don't need to remind him like each time, it's much more fun for him to work because he can focus on advancement.
Correct, but there is a problem. When you have when you have a shared memory, the whole company, all developers are keeping their sessions from the Claude Code in the same memory. And when you put all the code in the same memory, you have extra power that everyone else doesn't have. I will give an example. You are a developer, you're working on a new feature, and there is another developer which is working on another feature. You don't know about those features. You both are not talking. But because you're using the same memory and same session, the Claude Code for both developers will mention that both developers are working on parallel features, and will know that they need to change something in the code, so those features will combine together in the future. So this is something that developers figuring out after they're doing the pull request, not before.
Anton, you can create reports for the VP R&D or CTO.
Who did what, who was working on what, how much tokens spent, what code was written, how much pull requests were created. Exactly. And this is what's called institutional memory. When you put in everything, Claude Code, sessions, and think about that. If you connect to these agents, now the agents know about what humans were doing. and humans know what the agents are doing. So now we have actual collaboration, actual memory.
Yeah.
This is right
Synergy
now called
between,
institutional memory.
yeah, it's like synergy between all the team members. It's super
Yep.
important for working together.
And it's not what I invented. This is where market is moving. So, for example, Oracle Cloud is very right now going over the market and saying that, hey, we have a lot of those vector databases. Build your own brain, build your own memory. The whole idea that with DevMind and with the Kuberly, I put in a memory only like a coding and knowledge about the coding, and for the Kuberly infrastructure, knowledge about the infrastructure. But in reality, other companies will be putting their business data inside the memory. And this work is actually complex. Why it's complex? Because whoever is going to put this data inside the memory, first of all, will need to understand the business of the company. We'll need to understand how the AI agents is working inside the company, how the data is look like, and how he can build this classification and embedding process on top of that data, how he can build this learning process on top of the data. Yeah. Okay, let me show you a few more things. And I think that's it for today. I want to talk about 3 roles, which I see right now on the market and which are emerging on the market. So we discussed that right now, companies already started to build what I call institutional memory, what other companies call AI brain or second brain. Doesn't matter. That's the idea of keeping all the sessions, all the context, all the company data in one database. So you have a collaboration, and what's important, you have a history. So for example, me can work after another developer, or another developer can spin up my old session 6 months ago, and he
Anton,
can continue.
how much it costs to store all this information? Because it sounds
Not much. No, not much. I also thought that it's going to be expensive, but then first of all, I did it on AWS and I did it on Amazon native models. Everyone on this call who is going to listen need to know that Anthropic is not providing embedding and classification models, so you cannot do the actual RAG using only Anthropic models. So you will need to look for alternatives. And for example, very good alternative when you host it on AWS is basically to use the native models. And they are native models. I already calculated how much it costs, and it's super cheap. Like we're talking about $10-20 per month just to doing the constant indexing.
on Bedrock?
It's super cheap. On Bedrock, exactly. Yeah.
Mm-hmm.
But the infrastructure itself, yeah, it will cost some money because you need to run the database. Database costs like 2 CPU, 4 gig of memory, then the storage. So at additional like $200-300 you will need to pay per month, of course, to keep this in infrastructure.
Yeah.
But what
the
it gives to
trade-off
you,
is
and how much
gives you-
it saves you tokens. That's also, it will save you more than you spent on this infrastructure. So let me say, there are 3 roles which I see right now on the market. Someone will need to go install those databases. Someone will need to go and configure those databases. So there is a need of DevOps engineers or platform engineers, you can call it whatever you want, but those engineers who knows vector databases, graphs, docs, all that stuff. The amount of such engineers is very small because you need to be someone who's doing the installations, but at the same time, you need to be data engineer. So the merge is very small.
Mhm.
Amount of engineers who can do that is very small at the moment. Second one.
big salary guys.
Yeah. Second one, I already mentioned to you that putting the code is okay because we know what the code is. We can train on top of the code. We can grab a lot of open source coding repos and train on top of that. So there are ways to work with that. Same goes to the infrastructure. I know what to look. I know how to train on top of it. That's clear. But business data, completely different story. Because as I mentioned to you, you need to understand data. You need to speak with the business, to developers, figuring out how they're working with that data, and so on. And this is what's currently called the forward deploy engineer. That's what they're doing. They're doing 2 parts. They're coming to the companies without AI agents at all. They're speaking about their business, and then they're proposing how to build the AI agents, and then they are building the agents or just consulting. That's the part number 1 of the forward deploy engineers, what they're doing. And part number 2, what they're doing, is when the company already has the AI system and company wants to get the better results. This is where forward deploy engineer, again, listening to the business, checking out the data and figuring how to build a RAG, DAG, all those databases on top of the data so the agents are working more better. This is the second. Those guys right now, they're getting, I'm not joking. The salary is up to $1 million per year. No joking, in California. Because right now there's not enough engineers who can actually figure out how to put the data in the RAG, DAG, and so on. That's the second role.
What's your take on people that want to get into being experts? What they need to do?
Give me a second. Let me speak about the third role, and then we will discuss this. The third role doesn't exist yet, and market even doesn't know about it yet. Some companies may be already faced with that, but there is nothing about. And again, I will probably give up a lot of ideas for startups, but anyway, it will happen. So we discussed that let's put everything to the memory, to the database, correct? And let's have a history. But you understand, you should understand that the memory is going to be corrupted at some point of time because people wrote something wrong, AI delusion. So memory will be becoming worse and worse and worse and worse over time. And once it's becoming worse, it's affecting your results. So your results will be worse. And at some point of time, this memory will become very, very bad. So what do you need? I'm like joking. You need a psychologist for AI, right? Because if it's a brain, then you need a psychologist, right? But in reality, we need an engineer who will be constantly looking over the data, who will be cleaning it up, who will be...
You need to understand the business
this data.
super
Yes.
deeply.
Yes, understand the data.
CEO, developer, I don't know. It's crazy.
I don't know as well. I'm just saying that there is a problem. I'm in this industry, in this like problem with the memory for more than 1 year, and I already faced it. Yes, memory is getting worse over time, and you need to clean it up. And in order to clean it up, there is no tools, there is no nothing. There's no methodology, no tools, no visibility.
You cannot
nothing.
clean it without knowing the business. It's really something, maybe it needs to be done like, I don't know how. Maybe it should like...
I'm just saying that there should be tools. Yeah, someone should be reviewing it constantly. Yes. And I think AI should be doing that. But again, there is no platform, no solution for that. And I can tell you that market even not thinking about it. Everyone is right now on this stage or on this stage. So everyone are only thinking about building memory, or there are companies which already put in the data inside the memory, but no one is thinking about how we're going to clean the data. What's going to be the solution or tools? So idea for a startup. Guys, start building something which will be helping to clean up the memory.
Unicorn of 2020, I don't know what,
2028, I guess. Yes.
9-8.
Cool. 9-8, yeah, somewhere there, yeah. And I believe this should be 3 different roles. Right now, as I see, at least in California, forward deploy engineer covering all 3 roles at the moment. And I believe it will be splitted because one engineer cannot go to the calls and speaking about how to implement AI and implementing AI and figuring out the installation.
I hear today there is a trend of working 6 days a week, so maybe it is possible. Like in you know, in the US startup ecosystem, I saw something about it, that they are like going to work also in the weekend. I think like Israeli companies are doing it for years, but okay.
They're doing, that's true. But there is no name for that. There is no practices, no tools. This is what I'm saying, that even before the AI, there was like a need, usually from data engineers, to clean up your data, because even your data, your databases has a lot of very rotten and old data. Yeah, that's true. So right now there is a need for these data engineers, for someone who knows the data, knows how to put the data inside the AI, how to understand what to put inside the AI. That kind of engineers are lacking market at the moment. That's why anyone who says that he's a forward deploy engineer right away gets a big salary. Yeah. So this is it.
Cool. Okay, and I still want to ask the question from before.
Go on.
Give us the easy cheats because not everybody wants to become like a super mega expert in FinOps and have crazy methodology, but doing something that can give him like quick win.
Yeah,
What is
quick
that?
win. Two quick wins. First of all, the quickest win for you is to build the graph. Like put your database, put your data in a graph. If you're working with the coding, with the codes, with the repos, just use open source project, which is called Graphify. Build the graphs, and that's it. There's another project, you probably heard about it. It's called Obsidian. You can install Obsidian. It's building the graphs as well. Open source, very good. You will amazed how better results right away. I calculated from 17%. Once you build the graph, it jump into 40% right away. So right away, the answers on your questions will be much better. For what to build the graph? If you want to build the graph, not for the repos, not for the code, you will need to vibe code a little bit. Still, you can do that. It's not a problem. Building the graphs is very, very easy. So this is what you can do. Everything else is harder, but like graphs is the easiest. It will give you leverage right away.
Cool. Sounds easy and effective.
Correct.
Okay. Anton, anything else you think is interesting, like to conclude?
Yeah, to conclude. So as you saw, the whole usage of the AI is basically sitting in a context, in a cache, context cache. So whatever you want to do, if you want to make your AI working better, you need to work with the context. You need to make it better. If you want your AI agents to consume less tokens, you need to work with the context. So the whole work is around the context, how to give your AI better data, how to give less data, so it will find the correct answer. Yeah, so that's my take. One more thing. This is very, very simple. I think that everyone knows about it. But if you don't know, there is a project called Caveman. If you never heard about it, please take a look and install it. What Caveman does, it translates your language to Caveman language. So instead of asking AI, please do this issue, fix this, and please create a pull request, and so on, the Caveman will convert it to very, very simple Caveman language. Like, I need this, do this,
Now.
and so on.
Booga booga.
Booga booga, exactly. AI doesn't need your please, your like big description. It doesn't need all of that.
Cool. I really liked it. Cool, Anton. It was super interesting as always with Anton. Thanks a lot, and we are looking forward to see what crazy stuff we can do for our customers. And Anton is doing really amazing work, so it was like non-brainer to bring you for the first episode of this podcast. So thanks a lot, Anton, and have a great morning.
Thank you. You too.
Bye-bye.
Bye-bye.
That's a wrap on this episode of Token Economics. Find us on Spotify, Apple Podcasts, and everywhere you listen. Follow Profisea Labs on LinkedIn and visit profisealabs.com. Enjoyed it? Share it.